This video is to help with assignment 3.2, equations from a graph. In this equation, we see that it is in fact in y equals mx plus b format, where m is the slope and b is the y-intercept. So we look for the slope and we see the number right in front of x, right there is our slope, and the number right after x, right here, is our y-intercept. So that's all we need to put in here. Our slope is negative 5 divided by 4, or 5 over 4, and our y-intercept is 6. And that's all we need to do with that equation. Find the pieces and plug them in. Number 2, this one's slightly different. We have negative 3x minus 4y equals negative 20. We need to find the slope and the y-intercept. So to do this, we just need to solve for y. Because when we have it in y, we will have our slope and our y-intercept. So that's what we want to do. So we're going to put our box around the y. We're going to add 3x to both sides, leaving us with negative 4y equals, and we can't combine these. We have a 20 or a negative 20, and then we have 3 x's. Well, we can't combine those because these are x's, and that's a number. So we need to leave them separate. And so we're going to just put the 3x first and the negative 20 last. And just think of that as a number, not minus 20, it's just a negative 20. Now the reason why we want the x first is because in our example we want it to be y equals mx plus b. So now we're going to divide by negative 4 to get the y by itself. And that makes the negative 4's cancel out, leaving us with just y equals negative 3 over 4. We can't shrink that anymore or simplify it, so we're just going to put negative 3 over 4. It doesn't matter where the negative goes. You can leave it with the 4, you can put it with the 3, or just put it right out in front. And then negative 20 divided by negative 4 is a positive 5. So now we have our y-intercept. So we can just put that in as 5. And we also have our slope, the number right before the x. So we put that in here, negative 3/4. So on number 2, just solve for y. That's all you have to do. Number 3, write an equation in slope-intercept form. Okay, slope-intercept form is y equals mx plus b with the slope of negative 8, or excuse me, positive 8, slope of 8. Well, our slope goes right here, and a y-intercept of negative 7. Our y-intercept goes right here. So let's just create that equation. We see we have a y equals, that didn't change. What does y equal? Well, y equals the slope in front of the x. What's our slope? 8. So 8 and then x. And then our y-intercept goes after the x, and it's negative 7. So I'll just put negative 7. And that's all you have to do on that one. Just plug in for the slope and the y-intercept. Number 4. Write an equation in slope-intercept form with the slope and the y-intercept. Again, slope-intercept form is y equals mx plus b, where our slope is right here. So that's slope. And our y-intercept is right there. So we just plug in what we can. We're told what the slope is. Slope is 5. And we're told what the y-intercept is. Y-intercept is 8. So we plug in what we can. Y equals, and then we see our slope comes next, so -5, and then there's an x. And then our y-intercept is positive 8. That's all we have to do. Now write an equation in slope-intercept form. Again, that's y equals mx plus b, where we have our slope and our y-intercept, our slope and our y-intercept, then graph the line. Okay, so the equation, we're just going to plug in the slope and the y-intercept just like the last two. So y equals, and what's our slope? Our slope is 3 divided by 4. And then we have the x. And then our y-intercept is -5. Now we graph it. Our y-intercept tells us where we're crossing the y-axis. So right here. And then 3 over 4. If we remember, slope is how far we go up and down over how far we go right or left, or rise over run, or whatever you need to do to think of it. So our starting point is always our y-intercept, and then we go up 3, 1, 2, 3, and then over 4, 1, 2, 3, 4. I missed it. Up 1, 2, 3, 1, 2, 3, 4. And there's our line. And that's all we have to do to graph that. Number 6, same thing. We're given the slope and the y-intercept. And we're asked to put it in slope-intercept form, which is y equals the mx plus b. But this time I'm going to put it this way so you can see it a little differently. Whatever our slope is, x, and then whatever our y-intercept is. Okay. So let's put it in our equation. Y equals whatever our slope is. We see our slope is -2. And then whatever x. And then whatever our y-intercept is. Our y-intercept is -4. Now to graph this, we just need to put a 1 under the slope. Anytime it's a whole number, just draw a line and put a 1, because we need our slope to be, again, rise over run, or our change in y, which is up and down, over our change in x, which is right or left. So where's our starting point? Our starting point is always my y-intercept. So our starting point is -4. Just go to where y equals -4. And then my slope is down 2, because that's a negative, and then over 1. Now you can also go up 2 as long as the one is negative. So one of them has to be negative. It doesn't matter which one. Now write an equation for the line below. We're just going to write it in y equals mx plus b, where this is, again, my slope. And this is where it crosses the y-axis, or what's called the y-intercept. Okay, so we first want to see where it crosses the y-axis. It crosses at 1. Now what's my slope? From this point, I go down 1, 2, and then over 1, 2, 3, 4, 5. So my equation is going to be y equals my slope. We said I go down 1, 2, down 2, over, and how far did I go over from this point? I went 1, 2, 3, 4, 5. And then we have an x. And what's my y-intercept? It's positive 1. So I'll put a plus 1. And that's all you need to type in here. So y equals negative 2/5 x plus 1. And that's the equation for that line. Okay, same thing here. We know we're going to have y equals something, x, and then plus or minus something else. And this is the slope, which is also my rise or up and down over run, right or left. And this is my y-intercept, which is where it crosses the y-axis. So I can check right here, it crosses at 0. So I know that's going to be a plus 0. Now let's find my slope. From here, I go up 1, 2, 3, 4, 5, 6, 7. So I'm going up 7. Over. How far am I going over? 1, 2, 3, 4, 5, 6, 7. Okay, so I went over 7. Now let's simplify that. What's 7 divided by 7? That's just 1. So here I'm going to have y equals 7 divided by 7 is just 1x. But we don't need to put the 1. We just put x. Okay, we know we have 1x. And then plus 0. We don't need to put the plus 0. So if you want to put the 1x, you can. That's the correct answer right there. You don't need to put the 1, and you don't need to put the plus 0. But I think you'd get it correct if you did. Number 9. Write the equations for the vertical and horizontal lines that pass through those points. Well, our vertical lines and horizontal lines, not in that order, but our vertical and horizontal lines are always going to be either y equals or x equals. Well, what does x equal? Remember, this is x, y. So x equals 6 and y equals negative 5. So we've got the equations. Now all we need to know is which one is vertical, which one's horizontal. So if we sketch our graph, if we remember, if it's parallel, like this one's parallel to x, it means it will never cross x. Well, if it never crosses x, then x cannot be in the equation, only y. So our y would be a horizontal line. So we can plug that in for y. Y is horizontal. Okay, well, if y is the horizontal line, then x is the vertical line. And we can look at it this way. We can say, all right, x we have x equals 6, which is a vertical line. that means it's going to go up and down like this. Well, if it's vertical, that means it's parallel to y, which means it never touches y, and there's no y in the equation. So that's how we know it's the vertical line, is our x equals 6. And the last one, 10. Linear and nonlinear. Okay, so let me just tell you what's not linear. It is not linear if there's any exponent so like if it's y equals x squared, any exponent at all on a letter means it is not linear. Okay? Also, if x is in the denominator, or y for that matter, now I'm thinking y, x, if x is in the denominator, it is again not linear. Okay? So those are the two rules you need to look out for, if there's any exponent or any x or y in the denominator. So let's look at this first one. I see an exponent right there, not linear. No exponent, no denominator, linear. I see an exponent, not linear. I see an exponent, not linear. Okay, if you see an exponent involving a letter at all, then it's not linear. If the x is in the denominator or the y is in the denominator, again, not linear. So that's how you do 3.2. If you have any questions, let me know.